Hi everybody! This is my dog Coop. He just wanted to say hi before he started our math video. First I wanted to say I really miss you guys a lot. Not being at school kind of stinks. Maybe some of you don't agree with me, but I miss being at school and seeing you guys every day. He's getting sleepy. We're gonna do some math today. Yay, you're all so excited, I bet. But I just want to make sure everything's going good at home. You guys can email me whenever you need anything, even if it's not math related. Um, Also, I want to show you a quick little math joke before we get started, but make sure you guys have your 9.4 notes, proportional parts, and something to write with, and a ready mind. All right, let's get started. Here is my little math joke. What did the triangle say to the circle? You're pointless. Very funny. I know, you're all laughing. Alright, now to our notes. Notes. 9.4 notes, proportional parts. It should look like this. We've already done everything before this and we quizzed on it before we found out school was closed. I will just say those quizzes were not very good overall, but I understand there was a lot going on during that time when we took those quizzes, so understandable. All right, so if we look at this, it's showing us that in triangle PQR, ST is parallel to QR, and ST intersects the other two sides of triangle PQR. Note the shape of triangle PST. Are triangle PQR and triangle PST similar? So here's triangle PQR, and then here's triangle PST. Okay, so you have a big one and a littler one. So it's showing us since angle 1 and angle 2 are congruent, meaning they're the same, and angle P is the same as angle P in both of the triangles, the small one and the big one, that our triangles are going to be proportional by angle from the last section that we did. Because if you have two angles that are proportionate, then the third one's going to be proportionate also. So if a line is parallel to one side of a triangle and intersects the other two sides, then the triangle formed is similar to the original triangle. This characteristic of a line parallel to a side of a triangle is expressed in Theorem 9(4). Okay? So we're going to do kind of, I think, more of like a review for these next few. So complete the proportion SV, SR, and something RT. So SR is this big triangle. RT is this big triangle. So we need to find something that is similar to RT. So SV is this small one. The similar side of the big triangle for this one is VW. Okay? And this next one, complete the proportion ST, this big one down here, and SW. Sorry, my lines aren't very straight, obviously. And we have SR, is a big one, and we need something on the bottom. For this one, SV will be this side for the small triangle. Okay? And now we get to something a little trickier and including some algebra since it wants us to find the value of x. Okay? So we know that these two triangles are similar. So we have parallel, sorry. It's showing us that line JK and GH are parallel. So we can make some proportions. So I'm going to do this big side, which 6 plus 3 is 9, over, we're going to do this small triangle now, 6. And we're going to go down here. The big triangle is going to be x. And the bottom triangle is going to be 8. Okay, and then we're going to cross multiply. We've done this before. I'm going to use my phone for a calculator. (72) equals 6x. Divide. X equals 12. Okay? And then this next one, same thing. It wants us to find the value of x. So we're doing some algebra. I'm going to take this side of the big triangle up top, 8. And then the same corresponding side of the small triangle, 4. And I'm going to take this big side of the triangle, which is x, and then the small side of this triangle, 5. I'm going to cross multiply again. And I have 40 equals 4x. Divide. 10 equals x, or x equals 10. Okay? Then we're going to come up here. Okay, so this theorem, if a line is parallel to one side of a triangle and intersects the other two sides, then it separates the sides into segments of proportional lengths. So if BC is parallel to DE, then AB is proportional to BD, and AC is proportional to CE. Okay? So in figure RS is parallel to UW, find the value of x. So we have another algebra type problem here. So we can look at this smaller triangle, right? And we know from this postulate or theorem that this side is going to be similar to that side or proportional, and this side is going to be proportional to this side. So we can go smaller proportional to that side, and this is going to be proportional to this one, x plus 2. Can cross multiply. I have 4x plus 8, because we can't forget we have to distribute here, okay, equals 5x. Get the x on the other side. So I have 8 equals x, and that's my answer. Okay, we can move up again. We know that these GH and BC are parallel, so we know that this side corresponds with this one. This side corresponds with this one. I just make these little dashes so I remember which sides go together, like match up on the two shapes. If you guys have a different way of doing it, go ahead and do that. But we are finding the value of x again, so we're going to do some more algebra. I'm going to start with this small triangle, 3 over x. Small triangle again, 4 over x plus 5. We're going to cross multiply again. Don't forget this one, you're going to distribute. So it should be 3x plus 15 equals 4x. Get the x by itself. 15 equals x. Okay? Okay, and this one wants us to explain why triangle NRT is similar to NPM. So we have the small one and we have a bigger triangle as well. So something that we know is that if these two lines are parallel, we know that this side corresponds with that one, this one corresponds with that one, and these angles are going to be the same because they're corresponding angles, and this N is going to be the same because it's the same angle in both the small triangle and the big triangle, they share this. Okay, so now it wants us to write 4 proportions for the triangle. So I'm going to start with NR is proportionate to NP, the big side. I'm going to say NT is proportionate to NM, the big side. I'm going to say that RT, the small side, is proportionate to the big side, PM. And I'm going to say, because we know these lines are parallel, NR is also proportionate to RP. Okay? Alright, so then this last one, Ranger Lopez wants to know how tall the tree is that she planted 5 years ago. She walks away from the tree until the end of her shadow and the tree's shadow coincide. Use her measurements to determine the height of the tree. So we have this small triangle over here, which is 5 feet and 8 feet. And then we have this big triangle. Here's the tree. See that? This length is 26, but it stops there. And then we have 8 the rest of the way. So the proportion that I'm going to make is I'm going to start with the height of the person. And I don't know what the height of the tree is. That's what we're looking for. So I'm going to make that X. I'm going to put that there. Now I need to make a proportion with these bottom sides. So I know the side of the small triangle is 8. And the big one is not just 26. We have to add these 2 up. So I get 34. Now I can cross multiply. Sorry, I need to use my calculator again. I'm not that good at multiplication. Maybe my phone will work. Come on. There we go. 5 times 34. 170. 8x. Get x alone, divide. And I get x as being 21.25 feet. So that is how tall this tree ended up being after 5 years. So we will be doing 9.5 on Wednesday. We should have 2 pages filled out from today's lecture. And I will see you in 1 second. I gotta change my camera. Hope that those notes were... So hopefully that was easy for you guys to follow. If not, go ahead and shoot me an email and we can talk about it and clear up anything. Tomorrow we will have a Zoom session from 10:30 to 11. Tomorrow's Tuesday. And we'll be able to answer any questions you had from the homework or from the notes. Me, Miss Chesna, and Mrs. Lindquist will all be in attendance to the Zoom meeting. If no one shows up to the meeting by 10:40, we are getting off. If you guys need it, you'll be on at 10:30, I hope. Again, if you have any questions, email me. Even if it's not about math, go ahead, shoot me an email. We are all here for you. I know this time can be very troublesome and uncertain, and we are here to support you. So hopefully that those notes are okay. It was a little rough on my part, sorry. E-learning's new. But see you guys tomorrow. Bye.